In this section, we will cover a review of the Browns Ferry nuclear plant fire. This section will explain the maintenance that led to the fire, review the major events during the fire, and explore the immediate cost of the fire. The Browns Ferry nuclear plant had consisted of 2 operating units, with a third one under construction. The units were designed to have a single common control room, which was housed in a separate building than the reactor units. The wiring for the control room went underneath the control room into a cable spreading room. The illustration here shows the location of the control room for all the reactors and the cable spreading room underneath it. The outline of the reactor building 1, which housed Unit 1, is also shown. This is a more modern picture of the cable spreading room. Here, electrical cables were placed in several 4-foot-long metal trays before going into the reactor buildings. The design was made to house cabling, not people, as you can clearly see. This meant there would be many trays in the room that were very hard to gain access to. Many different wires were running through each of these metal trays. The schematic here can show that there were several different units going through all of the trays. But the plant design ensured that none of these trays would hold the power and the control lines for both parts of any redundant system. This was to ensure that a single fault could not eliminate both the primary and backup methods to any vital systems, and was a prescribed requirement by the Nuclear Regulatory Commission. The trays would pass through a polyurethane sealed penetration before going into the reactor building, such as the one shown here. The polyurethane material was initially thought to be fairly resistant to fires, but it could not be proven to be considered a fireproof material. A fire retardant was applied to the polyurethane on both the reactor side of the building and the cable spreading room side. These penetrations were part of the secondary containment barrier and needed to provide an air seal between the cable spreading room and the reactor buildings. The plant's ventilation systems were designed to force air to flow to the hard places of highest radiation. This was to ensure that during a reactor accident, when a reactive particle had the greatest possibility of getting released to the environment, all airborne particulate would be carried back to the reactor's refueling room, which was the place of highest radiation. While upgrading the plant, many of these air seals had holes pulled through them to allow for installation of additional cabling. Now this was fine, and it still met the requirements needed to keep secondary containment under satisfactory levels. But during the construction of Unit 3, the Tennessee Valley Authority conducted tests to see if Unit 3 could be added on to the ventilation system with the other 2 units. It was found that the gas treatment system that had to exhaust air from the reactor buildings to maintain a relative vacuum in them could not support the additional building unless the air seals were repaired. The Tennessee Valley Authority would start a long process of documenting and repairing the hundreds of holes found in secondary containment. On March 22, 1975, several electricians and inspectors were working to locate and repair the air seals in the cable spreading room. It had become a common practice to use a candle to locate air leaks in dimly lit, hard-to-reach spaces. If there was a leak present, the flame would be pulled towards the air leak. An electrician could seal the air leak using foam polyurethane sheets, and an inspector could use the candle to ensure that the air seal was adequate. At around noon, an engineering aide was using a small candle to find air leaks. While looking in a hard-to-reach area, a leak was found. The electrician working with him could not reach the leak, so he gave the aide some of the foam sheets of polyurethane to seal the leak. The aide quickly installed the sheets. Around 12:15, the aide held a candle about an inch away from the installed polyurethane sheets. The candle revealed that the job had been severely inadequate and pulled the flame into the penetration. The polyurethane instantly began to sizzle and burn. The aide told the electrician that he had started a fire with the candle. Everyone in the cable room started to react, but the aide was handed a flashlight to beat the flame. The flames continued to burn. He was handed rags to smother the flame, but the flame was being pulled through the wall into the vacuum on the other side of the reactor building. Workers scrambled to find portable fire extinguishers, but many of the fire extinguishers brought were not operating as long as they should have, and could not put out the flame. The aides saw that the flame had spread through the wall into reactor building 1, so several workers ran out of the cable spreading room to fight the fire there. On their way to the reactor building, one of the workers finally told the public safety officer about the fire in the reactor building. This public safety officer relayed the message to the shift engineer, who finally announced the fire over the plant's public address system at about 12:35, which is 20 minutes after the fire had actually started. Eventually, a shift engineer decided that the casualty would need outside intervention. He would finally inform the plant superintendent of the fire around 12:55, 40 minutes after the fire had started, even though the plant superintendent was listed as the first person to contact the second a fire was announced. In the cable spreading room, the engineering aide continued to discharge dry chemical fire extinguishers at the fire. 2 additional extinguishers had been used, but they had failed to discharge as long as they should have. With no additional input from supervision, the worker there continued to search for working fire extinguishers. An assistant engineer in the control room was reminded about the CO2 suppression system installed in the cable spreading room, and he sounded the alarm to evacuate the workers there. After verifying personnel had evacuated the cable spreading room, the assistant shift engineer attempted to actuate the CO2 system. He found that it had been electrically disabled to ensure personnel working in the cable spreading room would not get shocked by its power lines. The assistant shift engineer ran to the other side of the cable spreading room to energize the system. After locating the power switch, he energized the system, but he did not hear the system automatically discharge. He went to manually initiate the CO2 suppression system, but he found a protective metal plate had been installed over the manual actuation. This was to ensure that the construction workers who had been working on Unit 3 did not accidentally initiate the system. Without the proper tools to remove the plate, manual initiation of the system was impossible. Luckily, the system began automatically discharging to the cable spreading room while he looked for tools. Meanwhile, in the reactor building, workers just started showing up on the other side of the cable spreading room. They were only repair guys, and they did not know where the cable trays they had been working on were located inside of the reactor building. When they found them, they realized that the trays looked like this illustration. They were roughly 25 feet off the level of the reactor's building, and eventually they would finally find ladders so that portable extinguishers could be used on the fire. But the lack of proper ventilation caused that area to quickly become uninhabitable. The rest of the firefighting efforts proved that fire safety was not a priority at the Browns Ferry nuclear plant. In the reactor building, several workers attempted to fight the fire sporadically by getting portable fire extinguishers and attempting to route temporary power lines to ventilation fans to clear out smoke. The efforts were not coordinated at all, since all the shift engineers had ran to the control room to help assist the operators there. The workers were not very knowledgeable about firefighting at the plant and could not locate air packs to allow for more people to fight the fire. When they did find air packs, they found that many of them were in disrepair and could not be used. Even after the Athens Fire Department arrived around 1:30 p.m., many of their recommendations would not be heeded, and no effective firefighting efforts would be implemented at the reactor building for several hours. In the cable spreading room, the CO2 suppression system would prove to be much less effective than predicted. It would be actuated 3 separate times before it actually contained the fire in the room, and the fire would not be announced as out in the cable spreading room until 4:30 p.m., 5 hours after the candle had started it. The reactor building would not be so lucky. Although the Athens Fire Department had recommended using water on the fire around 2 p.m., The prevailing theories at the time suggested that water could short out vital systems which were necessary to shut down the plant and keep the plant cooled after shutdown. Firefighting efforts continued with the use of nothing more than portable fire extinguishers for hours. While temporary lighting and physical rope guidelines had been routed to aid the firefighters, the efforts continued to prove to be completely ineffective. A shift engineer did not allow the use of water until 6:40 p.m. The firefighters utilized the hose in the reactor building, but they found that the nozzle would not get the water high enough from the floor to effectively combat the fire. They attempted to use their own nozzle and found that the threads on their nozzle was different from the threads on the hose, and it would never fit properly. Finally, a shift engineer took the hose up a ladder and put out the apparent fire. He left the hose wedged against the ladder and continued applying water for the next 15 minutes as he evacuated the building. The fire was announced out at 7:45 p.m. that night.